reinforcing it much through the year. And so in the past, I've done this like first chapter of school, and then I ended up having to reteach it at this time anyway. So I was like, well, then I'm just going to teach the first time right now. So there we go. That's why we are now just kind of sticking this random chapter here at the end. So what the goal of a simulation does, there's really two goals that a simulation can do for you. Okay? One is you can use a simulation, or you can use the information from this in describing how you would randomly select something. For example, on this first problem, we're going to be describing how we would take a simple random sample of our class to get 4 students. Okay. Well, if you remember experimental design at the beginning of the year, I used to say, okay, the simplest way to say this is to say, put all 30 students in a bag, shake well, and then randomly pull out 4. Okay, well, the logistics of that, are problematic. So you could then technically finish out, like actually do a real random sample of a class of 30 or of 400 dogs or of 60 babies, whatever, without putting them in the bag and shaking well. You could complete with this random number table, and this how we're going to describe this is going to help you know what kinds of things you need to say. Okay, so there's one thing, picking a simple random sample. The other is actually simulating the probability of an event. Okay, so you can come up with this situation and you really want to know how many you expect to find, what's the probability of something happening, and so you take a simulation and you think that it's not necessarily going to be exactly the answer, but it's probably going to get you what? Pretty somewhere in the ballpark. Get you pretty close, okay? Globe life. Here we go. All right, so this thing, I have a little mnemonic device which I am having trouble kind of making it something that is catchy or something you can remember. So if you can remember, every learner uses a random sample accurately, which I don't know how you can remember that, but we also are going to use, I know, I need help with how to remember this stuff. But these are the letters that are going to start our sentences, and this will help us remember all the components we need to include. Elarsa, like a dinosaur. Dinosaur, Elorsa, I don't know. Okay. Alright, so here we go. Number 1. I wish to select a simple random sample of 4 students from this class. That's the goal. And there's a class of 30, and they're going to participate in a survey. Indicate how I could use a random number table to do this. Include a careful description of how the digits will be assigned and how this selection process will occur. Use the accompanying random number table below to demonstrate how you would make this selection. And then you will be asked to do this in the event that you do one of these processes, to mark on or above the digits in such a way that someone else reading your paper could follow your marks. Okay. Now, when you look down here at your number table, okay, when you look down here at your number table, these are actually in little chunks of 5 digits. All right? There's no reason for that except for the ease of your eyes and looking at them. If there's a whole chunk of numbers being all together, then you can kind of get messed up and your eyes shake or get cross-eyed or whatever. Technically, here's how one is demonstrated. Here's what one looks like on an actual AP test right here. So this is 2001. We did a simulation. You can see that these digits do have this gap every 5 numbers. Now, when you're counting, you can go across the gap only for ease on your eyes. And you can continue on to the next row without stopping as if it was a continuation of numbers. Okay? All right. So, let's go back here and do this. First thing, letter E. So, I've got the sentences already typed out here, actually. So, I'm going to guide you step by step through 2 of these, and then you're going to practice the third. Okay, the first one, what we want to say is that each two-digit number, so this is going to tell us how to represent these students in the class with numerical digits. Each two-digit number represents a student in this class. Okay, so my question about that is, why could I not just say, assign the students a number from 1 to 30? Okay, so some people are 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that's one-digit numbers. And then you start 10, 11, 12, and then you start with two-digit numbers. What's an issue that might happen when you have some people that are one-digit numbers and some people that are two-digit numbers? What kind of problem might that pose when you have a number table like this? Perfect, that's exactly right. If you pick a number, is this number supposed to be 4, or was I supposed to pick 43? Was I supposed to pick 0 or 90? Was I supposed to pick 5, 54? What? Okay, 546? Okay. So what you have to do then is say you want all your digits to be the same length. So whatever is most limiting, if you have something that goes up into 1,000, you're going to need four-digit numbers. Okay, and so on. So mathematically, what would I assign somebody who is a number 1? How would I do that with two digits? Good, 0, 1. Okay. So, in fact, that's what the L is for our next line. Let the numbers 0 through 1 to 30 be assigned to a unique student in this class. You may think that this right here is not essential. It actually is a very important thing because in a very succinct way, I can say that a student doesn't have two numbers, like Tyson doesn't have 0, 1 and 27, okay? Or vice versa. The number 15 isn't given Sydney and Corbin, okay? A unique one-to-one relationship between the numbers and the students. Okay. Next, the U. Oh, wait, hold on a second. Okay. I did this backwards. This is supposed to be UA. Yeah.
I have a question real quick though.
Okay, go.
Okay, say you have 0, 1 through 30.
Okay.
What about 31 to 99?
Correct. We're going to address that here in a minute because that's a problem. Coming across a 31 to a 99, also 0, 0. That's another two-digit number. Okay, that's what makes the hundredth value. Okay, that one is a problem also. So we're going to address that shortly. So hold on to that. Okay. All right. The next one is supposed to be a U, which means telling us what you're going to do. You're going to use the random number table below. Use the random number table below. So my bad. Let me fix that. Okay. And start with at the top left corner. Okay? Not in the middle, not at the bottom, whatever. Not in a random spot, which, you could do. Okay. Now here comes the A, which is representing, telling the person what a trial consists of. How long is a trial? When are we going to stop? When do we know that we're done? Okay? Can I have repeats? Are there any numbers I need to ignore? We're going to include that here also. So in this case, question, when am I done going through these numbers? There's like 5 lines of them. How do I know I'm done? With this problem, how do I know we'll be done? After I've done ELORs. Okay, true. I mean, the goal of this was to pick, okay, thank you. The goal of this was to pick 4 students. That's when I'm done doing this problem, is when I have picked 4 students. So, let a trial consist of getting 4 students. And this is where you have to address if repeats are okay, repeats, and if there are any numbers that you need to ignore. Okay? Like Tyson was wondering, what should we do with the numbers 31 to 99? Okay? If we come across those, Those don't represent a student, so we'll cross them out. We will ignore them. So that's what also goes on this line. A trial consists of getting 4 students, and when you go through a trial, ignore any repeats and ignore the numbers that don't count as a person. Why do I need to ignore repeats in this case? What if if I get 19 twice? What happens? Yeah, it's not unique. Correct. If I get 19 twice, that's the same person. I haven't picked an additional person, so I have to ignore a repeat. Good. All right, let's see what's next. R is next. That is what response comes out of a trial. In the trial, what will be the response that comes out in this case? When you're done with the trial, what's your response? The student's chosen. And then S is, I will tell you the last couple things in this ELARSA model kind of seem a little redundant on this particular problem. They make more sense on the second problem we're going to do. I kind of said the same thing a couple times. But we're going to actually go through choosing the students and marking on the table, and we're going to put who we end up choosing. So let's go through this. Okay, so, and let's show how we mark stuff. Pretend like you don't know that. Okay, so here we go. So I'm going to start. I'm starting at the top left corner. I'm going to pick 2 digits, and you want to mark on these so somebody can see what you're doing. So I'm going to underline it, the 2 digits I'm looking at. And what do you say about 13? Is that going to be a person chosen? So I'm going to label that number 1 because that's the first person chosen. And then I'm going to look at 96. So what am I going to do with 96? Okay, I'm going to exit out because that is not a person. And then I can go across this gap here. 27 is the second person who gets chosen. And then what's next? 09 is the third person that gets chosen. And then what about 92? That one's out. 65, that one's out. And then number 17, that is the fourth person. And I want you to draw a vertical line at the end of a trial. If this question maybe had another part to it or whatever, they might say, out of 3 trials, how many people got chosen more than once or something? And then you would continue. If they had asked you to, continue in another. So you want to indicate that vertical line at the end of your trial. And so then when I come up here to my statistic, that's the ones I chose. I chose 13, 27, 9, and 17. And the A is going to be redundant again on this particular problem. According to my simulation, I will pick students 13, 27, 9, and 17. But usually, because we're saying, according to this simulation, we have to account that this is the reason I'm telling you this, because these are the results I got from my simulation. Okay, good. So that one's kind of straightforward. Much more involved than putting 30 people in a big bag, shaking well, and pulling 4 out, So this is a little bit more annoying, which is why I didn't want to get caught up in this at the beginning of the year and saved it for now. But let's do this next one. Okay, our next one, number 2. Let's see if you can now kind of start guiding me through some of this. Number 2 says, what is the probability for finding 2 heads and 2 tails if you toss 4 coins? Okay. Now, yes, you could. Yep, you decide. You kind of think through it, and you decide what you think is going to be most easily representative of what you're doing in this problem. Yep. So we're going to be doing 20 trials to estimate this probability. Okay. So I've got coin tosses happening. So what do you want? Okay, odds and evens. Okay, so we're doing, do I need 2-digit numbers? You want to do 2 digits? So
or 1 digit. Doesn't really matter.
Okay, in this case, I think you could do 1 digit. Could you do 2 digits? Yes. All right. But I said let each 1-digit number represent a side of a coin. You first are identifying what a digit represents. Okay? Then you specifically assign them. And you say, let the evens, oh, by the way, did you know 0 is not considered an even number? And so the evens are 2, 4, 6, and 8. So if you want to make it 50-50, better tack 0 on there. That evens and 0 equal the heads on the coin, and an odds represents the tails. An odd number represents a tail on the coin. All right, so what's that going to be like? Use what? Random number table. There's one at the top of the back page, so let's just say below, because you'll go to the top. Use the random number table below and start at the top left corner. Okay? And then after that, we're going to describe a trial. So just think about that for a second. So how do you know when to stop? When is it says complete 20 trials. What has to happen for me to be done with one trial? Okay, I got that all day today. I got you getting 2 heads and 2 tails means you are finished with a trial. Okay, and so that means that you could flip up to 10. I mean, maybe you would get tails, 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 heads, heads. And then, then you picked 8 coins. And you did 8 flips. Okay? Is that what this is saying? It is not. It is saying you toss the coin 4 times. So the tossing of the coin 4 times is a trial. And then you are going to see if this occurred or not. Okay? So be careful in your understanding of what a trial is. So here, a trial consists of tossing 4 coins. And now we can think of repeats in this one. If I looked at a number table, let's say I looked at this top one up here. Let me erase all these. If I tossed these coins right here and I got, in this case, this ends up being a trial 5, 7, 7, 7. Is that problematic? Why is it not problem? Okay, even or odd, and this coin toss is independent of this coin toss, is independent of this coin toss. They're all independent of each other, so I can, and I need to have the same probability in there, so it's fine. Okay, that would just be tails, 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 and that could happen. All right, so repeats are okay in a trial, and then all the digits 0 to 9 are also okay. There's nothing I need to take out. Now, see, some people could have decided let a 0 equal a heads and a 1 equal a tails. And then what are you going to have to say? Ignore 2 through 9. Okay, see, somebody could design this problem that way. All right? But we did not. We did evens and odds, so all of our digits are okay to use. Okay, we're to the R, the response. What is our response going to be? At the end of the trial, what am I going to say as a summary of that 4 coins? What do I say? Correct. I got 2 heads and 2 tails, or I did not get 2. So it's a yes, no. I got 2 heads and 2 tails, or I did not. So the response is yes or no, that the trial has exactly 2 heads and 2 tails. Okay, so every trial you look at, you see, boom, yes or no. Okay? All right, so we're to that. And then the S is the statistic, meaning you got to go do the problem. So let's turn over to the back and actually perform this and mark on the random number table like we would be asked to do. So, I want to set this up into groups of what? Four. Okay. So let's just do that. Let's draw some lines, vertical lines at the end of our trials. So I'm going to go 1, 2, 3, 4. There's the end of one trial. Okay, so draw out, find your chunk of 20 trials. See where you're done. Go out to 20 trials. And there's 20 sets of 4. And so I'm now going to write a Y or an N on top of every single one of those trials as to whether or not I got my 2 heads and 2 tails. Okay, so go through there and do that. I took a picture of it earlier so I can do this fast. So let me find it so I don't have to keep thinking. Okay, so you might be doing that still, check to make sure that we're right. I got 7 out of 20. Okay, so that means that down here for my statistic, I write I got 7 out of 20, which is 35%, because after all, I am finding the probability of this happening. Okay? So the last thing, according to my simulation, see, there's my wiggle. Hey, I'm just saying what happened in my simulation. I'm not saying this is fact. And I also am saying about 35% of the time. I expect to get exactly 2 heads and 2 tails on 4 coin tosses about 35% of the time. Good. Now, while you are writing that, I want to connect this actually back to something that we did, because we've seen this. We have seen problems that would say this. Find the probability of getting exactly 2 heads out of 4 coin tosses. Okay? We did that as a binomial distribution. And on your formula chart, it looked like this. N choose K. Okay? And then we would go like this. And the probability of N choose K or something like that. And then you would go, actually, that's not where it went. But N choose K was a number. So we would go N choose K. The probability of getting exactly 2 heads is this, and then your number of successes, and I want K of those. K is how many successes you have. And then what's this? This was the failures and how many of those you have. I put some numbers in this to make it make sense. 4, choose 2 successes. What's the probability of getting a heads? 5, how many of those do I want? 2, what's the probability of not getting heads? 0.5, and I want how many of those? 2. Okay, so this is going to be the probability of getting exactly 2 heads. Now, do you remember how to put this in your calculator? Because we would never calculate this ourselves. We did this. So see, this is review, binomial PDF, because this was in particular exactly this many narcoleptic prancing kittens. Okay, you remember that? Jumping around prancing kittens, and then they just fall over asleep. Okay, where this number is out of 4 tosses, 50% probability, and then 2. So I would go to my calculator, I typed that in, and that's like, in theory, what should happen. It comes out to 0.3125, which is a 31.25% chance. Now, compare that to what we got with our simulation. And what do you have to say about that?
Pretty fairly.
Yeah, it's in the ballpark. Okay. Now, one other thing. Yeah, it's in the ballpark. It's what? Yeah, we could see if it's significantly different. Very good. But question is, why is this a little off? Sampling variability. It was off because it was done with 20 trials. How would I get it to be more correct? The law of large numbers. Woo! And I got a song for you. You ready? Okay. Now, if you do many trials, many trials, the cumulative probability. Okay, cumulative probability. That's what we're coming up with. The cumulative probability. Okay, I started too high. It will settle down to the true probability, which is this, 31. The law of large numbers, you see. Okay, so that's the bare necessities, you know. Okay, if I do many trials, many trials, the cumulative probability, it will settle down to this true probability. The law of large numbers, you see, okay? So that's what's happening. All right. Now, I'm going to pause and let you do this number 3. I want to see if you can do a complete ELARSA or whatever it's called right there, and we'll check it. Okay, let's let you check these. Okay, so I did each 1-digit number represents a child.
It's frozen.
Oh, thanks. I did each 1-digit number represents a child, and you could have done that. That's fine. It's all good. Okay. I did evens and 0 represent a boy. Now, if you had done the opposite, strangely enough, it actually still came out exactly the same if you had switched the evens and odds for the girls. I think that was a coincidence because it's not like each group had 2 or 3 of each one of the other, but anyway. So use the random number table below and start at the top left corner. A trial consists of 5 digits because you were getting 5 children. And again, repeats were okay because that just represented another boy or another girl. And all digits are okay. So the response variable is again a yes or no situation that I got exactly 3 boys and 2 girls. I ended up running this and I got 35%. So according to my simulation, there is about a 35% chance that the couple will have exactly 3 boys and 2 girls when they have 5 children. Okay? Now, how would you have done this problem theoretically with a binomial PDF? Because you would say, how would the question be posed? What's the probability that you find what? Something like this. What's the probability of getting exactly 3 boys out of 5 children? Exactly 3 boys out of 5 children. So that would look like binomial PDF of 5, 0.5, 3, and that's 31.25%. So again, very close to what happened in our simulation. Okay? All right, so there's that. Now, I have when you look at your homework, turn to that. I don't have a picture of it right here, but on the homework, number 3 needs to tell you to perform 20 trials. Okay, that one it did not have a stopping or how many to choose, and so you could see about how many of those you would expect to, how many households you would expect to have to pick until you find one that owns a cat and a dog. Okay, so there you go.